So let's skip the time. Yeah. So good afternoon and thank you for the introduction. I just had to disappoint everyone. I will not provide an answer. I will provide a contribution towards the answer. Anyway, good news is that I have a bridge in my presentation. The bad news is that I don't only have a bridge in my presentation. I am here to present several developments that we have been doing at our team in this concern at the University of Minho. A lot of people were involved here, so it's not only me, of course. And also, I will present several initiatives that have been going on with other institutions, and I will name them as they appear. So, first of all, the scope and motivation. I will be very quick here because I have a lot of obvious stuff in the middle of this, but I will go into them. We have been having BIM mandates all over the world in many countries. I am within one of those countries where you don't have such mandates, so our government did not have an issuing voice on this matter, and this means that we have been taking a different approach in the sense that we have to carry on the work with a more bottom-up initiative than usual. So I've been taking a lot of work in that sense, and but of course we have a lot of assistance from Building Smart and the CN Committee on Building Information Modeling that are actually providing a lot of information that is making our practitioners more aware of the subject of BIM, in particular in concrete structures, which are of course important in the supply chain. And we need new competencies, definitely, both on practitioners and also on our undergraduate studies and undergraduate students and postgraduate students that are giving us what the market really needs. This is one thing that really concerns us, again, in my country, is the sheer density of SMEs working on construction, and this has been spoken about before in a previous presentation. They don't have the capacity on their own to invest on this transition, and what I try to bring in this presentation is some sort of initiatives that we have been taking towards showing what more can you do with BIM than what actually the software gives you, and what more can you do with BIM than mere information management and collaboration processes. So I am focusing here a little bit on things you can do with programming towards extending the capabilities of tools towards what we really need as engineers. And there I am drinking a lot of my inspiration of what I felt when I worked as a full-time structural engineer. So let me shut up and continue. So I have the presentation divided in two parts. So as the challenge was to discuss the life cycle, the part number one is actually how to blend BIM into the life cycle. And I'm bringing here four hopefully inspiring examples, two of them at design stage, one mostly focused on the construction stage, and the other, which is the bridge, focused on the maintenance area. Then in a second part, I think it's important to provide a testimonial of the initiatives we have been undertaking, despite the fact that BIM is not mandatory at all in our country, and but we are managing to provide sort of an education to our students and to our practitioners towards making this more of a reality. And finally, the last ingredient, which is something we are very proud of, the European Master in BIM. So let's go in parts. Part one. So I want to speak about these four aspects, starting with one related to the design of thin concrete shells. So thin concrete shells are known to be a terrain where architectural engineers or engineering architects really fancy, because you need to have the two capabilities to design such a thing. And they are normally limited to people that have a very great sensitivity on the structural and architectural side. And what we wanted to do with this thing that I show you here, a framework for integrated project delivery in RC shell structures, was to bring about the possibility of a real-time interaction between a civil engineer, for instance, and an architect working on the development of a thin shell. So what we created was a framework that based on standard software. I will try not to speak about the softwares themselves, that's not the point, but using standard software that is feasible for this, we have this left-hand side screen, which is the environment where we are actually modeling the shell, the concrete shell, based on an architect's principle of the supports that should be given and the principles of what is the program that needs to be filled from an architectural point of view. And then with basis on such supports, we activate the dynamic relaxation methods. This is the hanging cloth principle, nothing new here at all. And then what we made was a framework that will allow the interaction directly under our total control of what are the parameters and the way of modeling that we see on a structural analysis software. And this allows us to have real-time information. As soon as we pick up a shape in according to the architect's intent, the structural engineer is providing instantaneous information, or even the architect can get it, under controlled modeling options. This is very important to give sensitivity to the structural engineer. So we provide information about stresses and deformations and hence the viability of the solution. This was made with this attempts of software, and in the end, of course, we end up with a BIM software and a BIM platform, which will yield you the final solution. So with these quick fits, we change shape and quickly get the feasibility, and then we also add the possibility of bringing, for example, a stiffener, which will make it viable to have other things. As an additional taste, one thing that we did was to add multi-criteria optimization processes, again with the standard methods of genetic algorithms, but we include several aspects which I will not go into detail, but you see here cost, solar lighting, structural performance. We also add a little bit of sustainability, but only from the demonstration point of view. We were not really deep in that, but then we followed this that we consider a very important aspect, the overnight calculation principle. So after reaching a solution between architect and engineer, we will let the computer overnight work on alternative solutions or improved solutions so that we reach something more interesting. So we're speaking about BIM. There needs to be a process map, but I will not bore you with information about the process map. But basically, with having an architecture and engineering discipline, we are putting the burden more on the side of the engineering because we were playing such role. Anyway, this takes 3 processes, as you see above, and the 2 first processes are the ones that pertain to the real-time interaction between architect and engineer, and finally we parameterize the structure and put it through an overnight calculation procedure. We found very interesting results, and for those, some are taking pictures, this is published in Advanced Engineering Informatics, and the point is the overnight calculation will bring you alternative shapes, not necessarily, we don't defend that we should adopt them, but often they will provide us with interesting inspiration towards design alternatives. So also this is just an illustration here on the left, top left side of the parameterization we do of the structure because it needs to be parameterized somehow. This is an amphitheater with the main lines of the amphitheater which will change height and length, height. And based on that, we can get the curly expectable situations that we get for optimized structural behavior. So then cost is decreased, but construction cost also increases, but this is the cost of material decreases and construction cost might increase. Anyway, going through several examples, this is my point today. I would speak about now integrated construction of arch stamps. And this is a particularly interesting thing for me, just a personal note because it's sort of a break. This is where I married my 2 fields of expertise because I really work on the thermomechanical calculation of dams as a scientific field, and then I decided, let's see what happens if we join this with BIM. And what we tried to do was to figure out first the geometrical aspect, and I am fortunate enough, and I always announce this, I don't see any reason to say that some geometry of any concrete structure cannot be modeled in BIM, and we put that to the test with a relatively complicated dam arch with double curvature, even though the mathematics behind it are not necessarily very much complicated. The solid you end up with is very interesting, and this is just the layout of what we were doing. So first we actually do the modeling of the medium sheet of the dam, then we give it some thickness. It gets sort of a skirt on the left and right hand side, but then we intersect it with the terrain. We add the dam's galleries. We are actually doing constructed solid geometry approaches, and we are just using standard visual programming added by code. And finally, we divide the dam in bodies. This is really important for those that are working on construction management of dams. And to put that all together, this is the illustration of the dam that we have. It's not a small dam at all. We have more than 50 meters dam. It's a nice dam in the north of Portugal that is not yet been built. It's still under some discussion, but it's got some galleries that we explicitly model them, including this water drainage vessel. And this is the result on the top part, the top left and top right. I draw your attention to this top right picture where you see the intricate intersection between the construction phases and the galleries. And the interesting thing is the degree of automatism to which we can create a new dam. So there's an investment into the creation of the first model, but then it really works nicely to produce a new dam, even though I must be truthful, the code to run the dam takes roughly 30 minutes to run, so it's not snap. Okay, but together with all this, the interesting part, in my opinion, is not the geometry. That's pretty obvious to me, but it's the fact that we try to blend in knowledge and to try to blend things that will assist us to take better decisions in quick and well-informed ways. So we came up with the coding of a thermal simulation software, a two-dimensional thermal simulation software that will make you a cross-section of the dam. And while we are studying alternatives of different thicknesses of the construction phases that will bring you a very different price on the construction, we are working on how can they be viable from the thermal cracking point of view. I guess most of you know, or you all know, that if you are too ambitious on your thickness of the lifting heights, you will have more heat of hydration and then more risk of cracking. So you have to invest a little bit of money in cooling the aggregates or cooling the water for the concrete, or using ice chips or nitrogen, whatever. There's a price to that, but in the end, if you are diminishing the time of construction, there you save a lot of money. So it can be worth it. So to study alternatives, instead of relying only on intuition, you can actually rely on the mathematics and the knowledge. But in the middle of this, there was still an obstacle. And the obstacle was, how the hell am I going to do all these construction phases and define a date for all of them? The software is not doing this automatic for me. There are no frameworks to do this. So we got inspiration on something that I used to work on in cement science, and I learned about this 15 years ago or something like that, which is the game of life. This was developed by a mathematician. The game of life is known also as cellular automation algorithms, and it's an interesting feature that will allow you, for example, to, based on sort of a chess tray with black and white positions, based on the blacks, you will make some rules, and then they start to evolve and create new populations of black areas, and then you get shapes or patterns such as those that you get in a snail shell or in a snake skin. Okay, those patterns are governed by very simple algorithms, and the field of science that deals with that within mathematics is cellular automation. So with the same principles, which are actually very simple, this looks complicated, but this is very simple, we would lay down the first stone and then second stone, I'm speaking figuratively of course, second stone according to a distance and a minimum height of neighboring layers. So then generating the construction phasing for each of the scenarios we were working was roughly immediate. So this was really immediate. So then we combining all of this, we could manage imagination on, not imagination, we could manage the simulation of actual construction scenarios with cost in the middle of all that. Another aspect, and this was spoken before, it was one of the last questions that was made to the previous speaker, what if we could virtually load testing our structures? As a structural engineer, when I was making design, I was very young at the time, and I often went home with a little bit of itchy feeling in my head, which is, did I design this properly? Was the design actually passed properly to the drawings? And did I check all the drawings in the sense that are they what I actually designed? So I had all these issues, and then eventually when I'm in this life of research, I thought, why not use the richness of a BIM model? Because more and more it becomes, I will not use the word cheap, but cost effective to do a BIM model together with the actual reinforcement. And the idea behind this, and this was actually resulting also from a conversation with Tom a couple of years ago, so thank you for the inspiration. With that, we we figured out, let's export this to a nonlinear finite element analysis software. This is the NLFEA acronym. And with that, let's try to put designers with the capability to export this to such a framework that will provide them with an estimate of the ultimate limit capacity of the structure just on gravity loads. Please don't make me questions about the earthquake. The answer will be, we didn't do it, okay? Just vertical loads. So what we wanted to assess was to what extent can we actually make this prediction, but at the same time, I have a lot of experience on nonlinear finite element analysis, and if you are working on cracked concrete, the constitutive laws are hard to put in the software, then it will suffer a lot of convergence problems. So we simplify the constitutive laws with some plastic behavior at the end, and particularly when concrete cracks, plastic behavior with almost zero stress. So there are a lot of features I could speak about, but there's no time. But anyway, with those simplified methods, convergence problems don't happen, and it's sort of mimicking a plastic analysis, plastic limit analysis that you would do on a hand calculation. But now we are using the three-dimensionality of the structure and taking into account the stress redistribution that happens. So of course, again, some programming happens there. We never get happy with the visual programming. We also always have to code a little bit more. Normally we use Python. And then this was a pilot structure. We did a lot of validations as well. There's a thesis written by my former student, João Ferreira, about this. So, then we managed to export this to the nonlinear finite element analysis, do a calculation in roughly 40 minutes of this structure in particular, and get the actual ultimate limit state capacity, which is cannot be seen as a real simulation, but as an approximation of reality. And comparing this with a real simulation with all the care that we could have in the world, we could get very similar load capacity. One thing that was really surprising to me, but at the same time very reassuring, was that when we tried to make some mistakes on purpose on the structure, a very interesting thing and a little bit unexpected in the beginning happened, was that you start to ruin the reinforcement of the structure, but provided you keep the geometry, it will be able to redistribute stresses, and this will cause the ultimate limit capacity not to change so much. So, of course, in the end of this, I was a little bit disappointed. So if it doesn't change, why the hell am I doing this? But in reality, service life behavior will change a lot. So this is the next step that we are going through. Detecting the mistakes in design will not be taken by the ultimate limit capacity. It will be taken by the cracking behavior. This will be a little bit more complicated, but we are very enthusiastic about it. Oh, by the way, the principle would be overnight calculation as well, because this is a very small structure, but if you get to the size of a building, that's a different game. We didn't go there, by the way. Please don't make me questions about that. But it is feasible, pre-answering your question. So, I promised bridges. Here are bridges. We looked a little bit about BIM inspection inspection and management based on BIM for bridges, and we had a case study where we worked on. This is a really small bridge compared to what was shown before, but the previous presenter shown the collapse of a bridge that happened in Portugal in 2001 by scouring of foundations, by the way. And this phenomena caused our country to be very careful about bridge inspection. So we have very strict rules that are very strictly followed, and we created national platforms to do that, and we have inspectors that are regularly doing that. So we partnered with Betar, which is the company that is very much advanced and authored the software that is widely spread used. And we worked on an example that we had to determine the load capacity for another client, DST, and they were asking us, what's the load capacity of this 1950s bridge? So we picked it up and we did an inspection as well. Of course, if you're doing BIM, if you don't put a laser scanner, you are not doing your job. So we put a laser scanner just to figure out also what we could get from there. And we were interested in geometry to begin with, but then we realized we had some interesting byproducts, which were the capacity to detect some warping, structural warping on the two main beams of the cross-section. And also, you see here we could get with I would say with a very decent accuracy, the deformation and the shape of the deformation of the bridge, which was not symmetrical. So this could give a little bit more of information, and even with subsequent analysis, we can get the evolution of the deformations. Then this picture is just a provocation. we were discussing how can we put this into a management system based on BIM. So the principle would be, if BIM has all the data, if BIM has the capability to have all the data, let's figure out if we can do an IFC-based way of making legacy information for future generations that can be built up and built up and built up. So we looked into several ways of doing this. We checked the literature, and the left-hand side would be the explicit representation of cores and the results of cores, the explicit representation of cracks. This takes a humongous lot of time, and this is not really, in our opinion, the way to go. So we decided to go to a patch-like alternative where we invest a lot on the information we put in each patch. So the green patches are biological colonization, and the red patch was a crack happening in an area of the bridge. Anyway, we focus a lot on the information, but I would not bother you on the details. We created a set of objects that we considered were important for us, like these balls that represent what we say are the spherical panoramas. We consider that, together with the bridge inspectors, that experienced bridge inspectors working with us, we consider that very important to subsequent reanalysis of stuff that we might not have figured out before. We assembled the photogrammetric image of the surface, but we have a lot of issues with the shading and color in between consecutive inspections. But then I think the most important juice that we did in our work for this was to figure out a way for inspectors that are not necessarily BIM capable, or they do not necessarily are capable of using a BIM platform, to put information into the BIM model. So we created a way through which, again, with some programming and with some API issues, we put an Excel spreadsheet where the objects were pre-identified. So a first inspection needs to be made by someone that is clearly BIM enabled. So this first inspection for the model needs to be like that. The principal inspection should be such. And then someone that is actually doing the inspection in site, they can populate, sorry for the right, oh, it's in English. So some Portuguese and some English. So then you could implement further information, and just by clicking a keystroke, it will send information to the BIM model. But of course, in this case, you have to have the BIM software open as well. And then, of course, the deliverables, we managed to get the similar degree of automatism in the creation of the deliverables that you do in a normal situation in BIM. So 22 minutes, and I still have part 2, but part 2 is smaller. So this is just to let the shaman know I know what I'm doing. And no training towards implementation. I will describe 3 situations that we've been working on. So the first of all is, I'm very proud, and the financial crisis was very interesting. It's important to mention this. The financial crisis assisted a lot. A lot of unemployment was happening back in 2011, 2012 in Portugal. And at the same time, I am working at a university, that is UMinho University, that from the point of view of importance, we are not in the main town, Lisbon, neither in the second town, Porto. So we are sort of fighting to get national recognition, and in a good sense, in a healthy way. But anyway, our department was more permeable to allow to have a BIM module in our course 1 semester, because we were getting differentiated. So this is an interesting story to frame the thing. So I had a lot of negotiable power to say, hey, do we want to make a BIM unit, a BIM module? Let's do it. So I managed to do it despite trying to do it 2 years before. I just managed in 2013, 2014 in the second semester. So actually 2014. 14 weeks of lecturing with 3 hours of theory in the morning, normally on Wednesdays, and 2 hours of practice in the afternoon. Normally this was an elective class, and we had 25 to 30 students per intake. This picture was not a standard class, by the way, because you may take me as a liar. Anyway, we had a practical assignment. So what we do is, these are 4th year undergraduate students. We provide them with drawings of actual constructions. This year they are making the campus, so they have access to the buildings that were actually built. And one of the things that I found very interesting was that the students learn a lot about construction. They didn't have much experience in reading drawings. Now they have to put the drawings in a model, so this makes them learn a lot about construction. And I love to see their innocence when they speak to me and they say, hey, professor, this is not as it was built. Why? And I say, welcome to the world, because nobody does it. So maybe BIM will assist us in solving that, but it's really interesting, and they learn a lot about the principles of what they are doing. And in the end, one thing that I also force them a lot, and nowadays communication is so much important, so I force them to create their own portfolio of their models, and they recently are including them in their curriculum vitae and making YouTube videos with that, and it's been working very nicely for the promotion of the university and of the students themselves, which is very nice. Now I reached the time limit, but I will take just a couple of minutes if you allow me, Tomo and Vladimir. The Portuguese National BIM Course for practitioners. At the same year in Portugal, we were bold enough to go to the National Engineers Association and say, let's make a BIM course. And they said, okay, let's do it. We joined a set of friends together, actually, with the University of Minho, the University of Lisbon Engineering, and the University of Porto, both engineering, and I'm sorry, the logo of architecture is cut because of slide setup. I'm really sorry, it's not on purpose. And we had the support of the Architects and Engineers Association, and we set up a course that actually is going now to the 9th edition. We are working on since 2014, we made a total of 8 editions, more than 400 people, practitioners that passed through us so far. The interesting thing is they created a lot of network between each other. They were sort of alone, and then they learned people that are actually with the same interests and looking towards BIM. Companies have been created, job mobility has happened, so this is really something that the market is willing to have. And we do the same. We do a practical assignment, but in this case, they do some sort of role-playing according to their background. So architects will play architects, and engineers will play whatever they actually want to do. And they make a test subject of a building or whatever after the end of the 9 weeks of the course, which takes place on Fridays and Saturdays. And yeah, they dedicate themselves, and they make a public defense in the end. And okay, there are just here some illustrations of what's happening in the course, which is very interesting. And now the end of my presentation, the BIM Plus, Erasmus Mundus joint master degree that we have set up together with the University of Ljubljana and Politecnico di Milano. So we are the 3 awarding parties, so we are receiving students, and we were funded by the European Union for a 1-year-long master with 60 ECTS. We actually have 27 non-awarding parties, meaning that the companies and other universities that are not actually receiving the students for the degree, but normally for the coursework. And yeah, we had the first intake. We had, I can say, more than 600 applicants for the first area, because we have really nice scholarships to offer. But I think the most the second call is open, by the way, in case you want to disseminate. Some scholarships exist. But the interesting thing about this master is what I felt, and you know, as I told you before, I'm teaching BIM nationally, and I clearly know my shortcomings. Even though the previous course that I showed, we are 17 teachers from different universities and in Portugal. But in this course, what we found was 3 members of the consortium, which are really, really complementary in their knowledge. So we divided our 6 units of the coursework, 6 modules of the coursework, sorry, according to complementary knowledge, and we are delivering them with separate responsibilities. And this is us smiling very much in our first meeting after we knew we were funded. Okay, and roughly that's it. Here's my declaration statement for the conference, and I am so sorry for taking 3 more minutes than expected. Thank you very much.
Thank you very much for a dynamic presentation. If there are any questions, comments that you would like to raise, you're more than welcome. Maybe just a quick question. How did you manage to bring together architects and engineers? I don't see any architects here.
No, that's a very interesting question, and I would say I didn't manage that yet too well. Okay. So what we have is, within our teaching staff, we have people from the Faculty of Architecture. So this brings the architects home to the home of the engineers, because this is actually taught in the National Engineers Association. So they are humble enough to go to the engineer's house, which is the specialty of architecture in Portugal is particularly non-technical, in the sense that they are sort of educated us mostly in the artistic part and not on the technical. For example, they do not make any design of the actual structure or whatever. They have less knowledge there, and as opposed to different countries. But basically, we got the support of their order of architects, and this support was materialized in dissemination that we could do in social media and whatever. And special architects come by to our course, but we have
what's the percentage?
1/5. Okay, 1/5, and this plays very well because we do the role playing with groups of 5, and all groups of 5 have one architect to role play their own stuff. So we don't put engineers doing architectural work. Yeah. Oh, but one thing, sorry. This is cultural, but I think it should be mentioned, and this is not a criticism to our architects in Portugal, but they have these credits that young architects need to earn to become chartered architects, and we applied that this course, because BIM is considered, in my opinion, is structured for a young architect to become an architect, and we applied to get this recognized as one course that could count as credits for them. But the present management said we are not supporting CAD courses. So they compared BIM to CAD, and in my opinion, this is wrong, of course, but this was the official response that we got. And I know this is being recorded, but I think that's not a problem anyway. So that is my answer. So it's not all flowers and easy. It's really hard. Yeah.
Okay. Any other question, comment? I always say to my students that they need architects because they need problems. Sure. If they don't have architects, they don't have problems to solve.
Yeah, that's. And I cannot fight that.
This problem is the initial design that they can convert to structural systems. So we really need them.
Okay.
Okay. That would be.
Okay.